Okay, recording started. Now let me share my screen. Good afternoon. Today's topic we will talk about autorecloser and sectionalizers. So before starting with this, I would like you to distinguish between two things. The first thing is called autorecloser relay, autorecloser relay, and the other one, autorecloser itself, autorecloser alone. Autorecloser relay, this is basically used in substations, and send command to circuit breaker for reopening or for reclosing. This is used a lot inside the substations, electrical substations. So it will send command to the circuit breaker to recloser, which means this is not a switching element. This is not a switch. It just send a command because it is a relay, which is send a command to the circuit breaker asking this to open and close. However, there is another thing which is called autorecloser. Autorecloser, this is used in transmission lines and especially in medium voltage. And basically, I would say it is actually a circuit breaker with recloser capability. So the recloser itself alone, without the relay, this is a switch. This is a circuit breaker or a switch. But it has an advantage, which is autorecloser. So it is a switch or circuit breaker that detects high currents, detects there is a fault, detects faults and trip. While the relay, it is only detecting faults and send command to circuit breaker to trip, asking for trip. Okay, so it's very important to distinguish between these two, autorecloser and autorecloser relay. What we discussed before in the previous lectures about the inside the substations, it was related to autorecloser relay. However, today we will talk about something different, which is autorecloser. Let's recall the single line diagram when we discuss here is like the step down transformer that's converting 132 kilovolts, this is by the way high voltage, to 33 kilovolt, this is the low voltage side. Then after that we said this is the 33 kilovolt bus bar. After that we mentioned there are some feeders. This is feeder number 1, feeder number 2, feeder number 3, etc. So there should be a circuit breaker here and a circuit breakers here. So these circuit breakers, they have the recloser capability. So I would say this is a circuit breaker, and there is another device. There is another relay. It's called autorecloser relay. So the autorecloser relay will be here in this area, inside the substation. Then after the feeders, we mentioned this before, that there are laterals. So here's, for example, lateral 3-1, lateral 3-2, and so on, lateral 3-3, etc. So each lateral, there should be a circuit breaker in case if there is any fault going on here or here, the circuit breaker should trip. Therefore, this circuit breaker, we will not call it exactly as a circuit breaker. This is circuit breaker with recloser, So we will say, instead of circuit breaker with recloser, we will replace this by saying this is auto recloser. Okay? Then here, what we have at the beginning of each lateral, this is autorecloser, this is autorecloser. However, here inside the substation, these two are basically circuit breakers without recloser. There is a recloser relay, but it's not a recloser itself. Okay, so that's the difference between autorecloser and where it's located, where is it located, and the autorecloser relay and where is it located. Okay, any question? I hope this is clear. All right, so let's talk about autorecloser now, then we will talk about the sectionalizer after that. So the autorecloser itself, it is a circuit breaker that's automatically open and closes after a fault. This is actually a circuit breaker because it's not a relay, it's autorecloser, and it is used a lot in medium voltage. Used a lot in medium voltage. What's the point of autorecloser, even if it's autorecloser relay? It is for temporary faults. We will clear the temporary faults without human interaction. As we said earlier, the vast majority of the faults are temporary. What do I mean by temporary? Which is from tree branches, lightning strikes, animals, and the thing about it, which is the, the, the fault can clear automatically without human interaction, or can clear after a short period of time, like lightning strikes or tree branches going into the power lines and falling down. And our target is to restore the service instantaneous and reducing the outage time. So if there is no recloser, we will send a maintenance team there. Then they will search for a fault. They will not find any fault at all. Then they will say, okay, there is no reason for the fault. Then let's return the power service. So this will take maybe some hours or maybe a lot of time. However, when we use the autorecloser, the power will back instantaneous in a very short period of time, within few seconds. So the thing again, we would like to make sure that again, to ensure that the device's autorecloser is used a lot in medium voltage uh, overhead transmission line, used in medium voltage overhead sub-transmission. The reason is to reduce the power outage, reduce outage duration, and limit the faults. And the other thing, isolate the faults. Isolate the faults, we will talk about it when we talk about the sectionalizer. So in real distribution system, again, as I said, in overhead medium voltage feeders, the fault happens due to, as I said, environment, like disconnecting the entire feeder. And as we see in this feeder, if there is power outage going on here, then we need to make sure not the whole feeder is being disconnected. So we would like to make sure to isolate the faults by using autorecloser and use the sectionalizer to isolate the faults. Then, when the fault occurs, there will be high currents. Then this autorecloser, let me say autorecloser A31, the A31 autorecloser will detect there is high currents. Then it will trip, the circuit will be open. Then it will wait for a short period of time. It's a pre-programmed dead time. then it will reclose automatically. If the fault disappears, the feeder continues working in normal operation. This means this fault is just is occurring only for a short period of time. However, if the fault remains, the recloser will trip again. Then it is unlike the fuses, the recloser can distinguish between the temporary and permanent faults. However, when there is a fuse, we need to replace the fuse. Then it will take a long duration, outage duration. When you look at this here, an overhead transmission line, we will see that around 61% of the faults are just transient or temporary, while 39% are permanent. As an example of it, when we look at the tree branches going to the power lines, causes the touching the lines causes three-line faults or three-phase faults. Then sometimes when there's a fault going on, there will be the tree branch can, for example, can be fired then, or the wind can move it, or because lightning strikes, or because of I would say like when there's a fault, the high fault currents can cause this tree branch to fall down. Once it's falling down, the main reason for the faults disappears, then there is no need to make a long power outage. The other thing, sometimes a lightning strike can touch the power line, causes a fault, which is over voltage, like a high fault. So if there is this thing, lightning strikes, it happens on for a short period of time. Therefore, after a short period of time, then the lightning strikes has been discharged, then there is no reason for the fault to continue. This makes the fault temporary. The other thing, sometimes due to wind, when there is a wind here, it can cause line-to-line faults. So these two conductors can touch each other due to wind. Then this can make line-to-line faults. Then because of the moving of the wind, then this touching will not continue forever. Then, for example, after that, they will be separated. And this situation, the fault's reason disappears, then this is a temporary fault. Another thing, if there is a bird can touch both phases. If one leg on the one phase and the other leg on the other phase, this causes the bird cause line-to-line faults. This can cause the bird to, for example, can explode the bird. Then after that, it will disappear because the bird can fall down to the floor, to the ground. Then the benefits, these kind of temporary faults, we want to reduce the outage duration, improve the continuity of service, reduce the maintenance cost, reduce the customer interruptions, and improve the reliability of the system. However, some other faults can be permanent. These kind of, like if there's car accidents, causes this power line or to be on the floor, on the ground, causes three line to ground faults. This is a permanent. Then, or if there is a cut in the power lines, then this can cause also a fault, which will create a big problem. So the autorecloser, again, it can be as an autorecloser itself, or can be as autorecloser relay. Then the philosophy about it, which is we need to, again, maximize the continuity of service. And it's, again, unlike the fuse where it operates, we can distinguish between temporary and permanent faults, while the fuse cannot distinguish, then the fuse can be just melted. After that, you need to replace it. And again, it's very important, the fuse cannot distinguish the fault types. Once it melts, the customer loses power supply until sending the maintenance team for replacements. Then the philosophy about it, it will trip, waits a short period of time, re-energize the feeder, see if this fault continues, it will trip again, then waits for a longer period of time, then re-energize, then see if it's continuous, it will do the last round, which is tripping, then after that it will remain tripping. So we need to make sure there is a specific, there are multiple attempts, it depends on the program, it can be 3 to 4 attempts. Then after that, after we identify this fault is permanent, it will enter the lookout condition. The lookout condition means the recloser will be open and stop re-energizing until a manual reset has been sent or until sending the maintenance team, they're asking them or making this going back to service. Now, let's look at this example, which is the first sequence, typical sequence, which is first trip, which is fast reclose to make sure if this fault continues or not. Then the second trip, this is the second scenario, fast reclose as well to see if there is a fault continues or not. Then after that, a delayed reclose for to wait if there is the fault has been moved or not. Then after that, it will reach the lookouts. Let me draw the sequence for you to have a clear understanding or a better understanding. Now, here is the fault. Assume the fault starts here, then continues forever. Here is a fault. Here is the autorecloser, the autorecloser condition. Now, the normal thing which is being on. Then, once the fault happened at this point, what will happen? The circuit breaker or the autorecloser will detect there is a fault, then it will go to zero trip. Then it will wait for a short period of time. I will call it like TD. After that, it will start re-energized. Once it's re-energized, it will back on. It is off. Then see the fault is continuing. Then it will back. So here is like the first cycle done. Then it will wait for a longer period of time. After that, it will re-energize again. Then it will trip for the third time. Then wait some short period of time. Then back again. Then after that, the fault continues. Then it's tripping. After that, here it will reach lookouts. It's reached the lockouts because it's tripping 4 times. Here is the first trip, second trip, third trip, fourth trip. Once reached the lookout, then that's it. We are done. This fault is permanent. Lookout, which means permanent fault. Let me draw another scenario here. Assume this. Here is the fault. Here is the autorecloser. So the fault, assume it's happening here, then eliminate it here. And that's it. So the thing about it, here's where the fault starts, here's where the fault ends. Then the circuit breaker is basically on. Then it will be off. Then there is a short period of time, TD. Then here is first trip. Then the second thing, re-energized. Once re-energized, it will realize the fault continues. Then it will trip again. This is the second trip. After that, it will wait for another period of time, then re-energize. Once re-energized, there is no fault. No fault here. Therefore, it will keep on. That's it. So when we reach actually there is no third trip, it's just like 2 trips. After that, no fault. Then basically, we will say that this fault is temporary fault. Temporary. Okay? Then here just we distinguish between the temporary faults and the permanent faults. Okay, any question? Okay, no? Okay, let's keep going. So for example, here we said like TD1 equal zero point 0.1 second. Here's TD2 equals 1 second. TD3 equals 1 second, and TD4 equals 5 seconds. So that's something that we can think about. We can add them here to this diagram, then that's all. Okay, so as an application, the we need to make sure there should be a coordination between the recloser. So we need to make sure the protection coordination, and we need to study the load currents, the short circuit currents, the fuses characteristics, the recloser curves, the ground resistance, and the arc characteristics. And here, when we talk about the autorecloser inside the or in the medium voltage lines, while inside the substations, we need to make sure to look at the transformer protection, the substation breakers, etc. If there is no protection coordination, this will cause maybe the sectionlizers working before the reclosers, or making the fuses working before the recloser, which is something that we don't want. How the recloser construction looks like, when you look at it, here's how it is. Again, it is a circuit breaker with recloser capability. Again, it is circuit breaker with recloser capability, as we see here. So we will see there is a high voltage bushings, protective tanks, the control line, the communication cable, and the mounting hardwares. Then when you look at it here in this diagram, we will see that the recloser can be as shown in this picture. So again, this is a circuit breaker. And circuit breaker that can reclose. So, which is again, that's why we call it recloser, which is it can reclose. The what's called this recloser can be a single phase or three phase. So, the single phase recloser can protect the lines, such as the branch, taps, or three phase feeders, and they can be as three reclosers to three single phase reclosers to make three phase reclosers. Again, the single phase reclosers can be used in single phase laterals, or can we reduce the unnecessarily three phase outages. However, the three phase recloser, it will trip all phases together, protective three phase motors, and or the any balanced loads from any faults going on. Okay. Now we are done with the recloser. Let's go to the next topic, which is the sectionalizer. So the sectionalizer, which is basically a device that does not interrupt the faults directly, but it is very important to isolate the fault areas. What do I mean by isolate the fault areas? It is, let's recall inside the high voltage substations, we used to say there is a circuit breaker and there is an isolator. We mentioned if there is any faults, the circuit breaker will trip. If there is no faults, or actually if there is circuit will trip, if there is a maintenance circuit breaker, it will trip. Once we do the maintenance, we will open the isolators. And we mentioned that the isolators opens at zero currents. Then the sectionalizer is something kind of similar in the concept of opens at zero currents. Once it's open at zero currents, there is no need for to have an arc extinguisher or to distinguish the arc. Then we basically just use when the current is zero, just the normal switch on and off. There is no need to use oil or SF6 for quenching the arc. Then how the sectionalizer looks like, let me redraw again the single line diagram when we mentioned about the 132 kilovolts to 33 kilovolts, and we mentioned there is a circuit breaker here, then this is the bus bar, then there is a circuit breaker for the first feeder, circuit breaker for the second feeder, and so on. Then in the feeder, we mentioned there is a recloser for lateral 1, 1, and there is another recloser for lateral 1, 2, etc. Then the sectionalizer can be added here as an example. We can put it here and here, like dividing the area into 3 or 1/3. Here is like 1/3, 1/3, 1/3 as a length. Then there is a sectionalizer. We call it S1. Here is S2, and here is R1. Here is R2. Then here is S3 maybe, and here is S4, and so on. So we will see in this lateral, when you look at lateral 1, 1, it has been divided or to 3 areas. Each area is being protected. The R1 or the recloser here, R1, this is associated with the whole lateral. Assume there is a fault happening here. So the first thing, the system will detect there is a fault. So R1 will trip. Once R1 is tripping, there will be no power for the whole line. After that, R1 will re-energize to return the power. Once we re-energize, the current is flowing here, there is a fault going. This fault is not temporary. Then the circuit breaker will trip again. The recloser will trip again. Once it's tripping again, what will happen? We will the sectionalizer S2 will be off. Once this is off, this region will be out of service. Then the recloser 1 will return the power to service. Once we return the power to service, the current flowing until here without any problem, so there is no fault. The good thing about it is this sectionalizer isolates this faulted area. But keep in mind, the circuit breaker will be on or the recloser will be off after the circuit breaker is off or the recloser itself is off. That's the thing that you need to keep in mind. So let me draw something here related to the faults. And here is like circuit breaker recloser, and here is sectionalizer number 1. Here is sectionalizer number 2. So here in this situation, assume the faults happen here and continues forever. Then, when you look at it, the circuit breaker used to be on until the fault occurs, then off. It will wait for a short period of time, TD. Then the power is back on. After that, we realize the fault continues, it will back off. Then it's off. And until here, the sectionalizers, both of them are on. Then, according to the coordination, we need to sectionalizer 2 works before 1. Then in this situation, after the second trip, here is first trip, after the second trip, it will cause sectionalizer 2 to trip during the off period of the recloser, while sectionalizer 1 is still on. Then, after that, once it's off, this area has been isolated from the rest. Then there is no faults. Since there is no fault or the fault is being isolated, then what's happening? The main reason for the fault disappears, then the power will be back on, then continues forever. So from here, based on this scenario, we can say here is R1, S1, then S2 is open for the faults. In this scenario, it is being open. How about another scenario? Assume like this. There is the recloser is located here. sectionalizer S1 here, sectionalizer S2 here. Then the faults happened in the middle between them, like a fault happening here. So what's happened? Let me do the plots. The faults happened here. Here is R1, here is S1, here is S2. So in R1, it used to be on until reaching the faults, then it will be off. After that, it will be for a short period of time, then back on. After that, the fault continues, then back off. So here is the first trip, the second trip. After the second trip, the sectionalizer 2 starts working. The sectionalizer 2 will be off. After sectionalizer 2 is off, this is out of service, but there's still faults going on. I mean, the current will not go here, but there's still faults. So the fault continues even though S2 is off. So what's next? The next thing, since this is still off, for a short period of time, then back, then they'll be off because the fault continues. Because again, the fault continues, it still remains off. Then once it's reaching this point, the circuit breaker or the sectionalizer number 1 will be off. Now, the first one fails. Let's go to the next one. If this one tripped, we will see if there's a fault or not. If there is no fault, then we are safe side. If there is remaining a fault, then the recloser will be off. Then the fault, after the third trip, S1 will trip. Then this area has been excluded. As a result, the current is flowing here without any problem, without any faults. Then we will say there is no reason for the fault continues. After a short period of time, the power will be on and keeps on. So as a result, we will say in this example, there will be power outage here and power outage here. That's the good thing about it, while there will be still remaining power here. There will be some powers here. Okay, any question? Now again, what's the sectionalizer? The sectionalizer is a switch with a control unit that's used to be counting the upstream operation, recloser operation, opens only during dead time. Opens at 0 currents. Which is we call again during the dead time, isolates. The main reason for that is to isolate permanent faults sections. So since it is being open at 0 currents, there is no need for arc QG. Okay. How does it work? So when the fault occurs, the recloser trips, then wait a short period of time. The recloser will be open to make sure is it temporary or not. Once trip again the second time, the farthest sectionalizer will start working, then start counting. If autorecloser is tripping again, then the furthest sectionalizer will start working, will be out or be off. Then after that, if it's going, the fault continues, then the nearest and the nearest and the nearest start to be off. As an example, recloser settings, 3 shots lookouts, and sectionalizers counts 2 interrupts. So the thing about it here is a recloser 1, sectionalizer 1, sectionalizer 2, and so on. So the first thing is R1 trips, then R1 recloses, So here's the first trip. If R1 trips the second trip, what will happen? The next sequence, it counts to sectionalizer S2 open. Then we will see, assume the faults again happening here. What's happening? If the faults no longer the fault occurred, R1 recloses, then no faults. Another scenario, here is R1, S1, S2, and the fault occurs here. So how's the situation? R1 trips, then R1 recloses, after that R1 trips again, then after that in this situation S2 open. Once S2 open, there's still faults. So there is a third trip. R1 trips, then S1 open. Once S1 is open, then we can say R1 recloses and no faults. How about another scenario here? Here is R1, S1, S2, and assume the fault occurs here. So what's the thing scenario? R1 trips, R1 recloses. The first thing here again, the main reason for that is to distinguish, to check if temporary faults or permanence. Then the next thing, R2 trips. During R2 trips, S2 open. Even though if we isolated this area, there is still the fault going on here, so the fault continues. Therefore, there will be a third trip. R1 trips. Then S1 will open now. Even though S1 is open, there is still a fault going on here. So, for the fourth time, R1 trips, then we will say we are in this region, then it will understand that this fault is permanence. Fault is permanence. So as a result, since the fault is permanence, the whole lateral is out of service. So again, the good thing about it, in scenario number one, then scenario number two, scenario number three. Scenario number one, we reduce the number of affected customers by 1/3. Scenario number two, because of the system capability, we reduce the number of fault regions to be 2. The scenario number three, or to be 2/3, the whole lateral is being out of service. This is happening 1/3, 2/3, and the whole lateral because they are in series. However, there is another scenario for the recloser to be in parallel. Here is the recloser, then here is a sectionalizer number 1, sectionalizer number 2, sectionalizer number 3, and so on. In this situation, there is no need to make a power outage for the whole lines, which means if there is S1 is not working, S2 will be working or not, then will be re-energized. We will talk about it, later in the later example. But here, I would like to show you that there is a recloser. There is a recloser here, sectionalizer, and the load. Then the sectionalizer will count how many should be on and off. Then after that, sectionalizer will be on or off based on the recloser. Will count how many faults is being on. Here is how the sectionalizer looks like. Again, there is no oil, no arc extinguish. So we don't need to extinguish the arc because there is no arc. Why? Because opens at zero current. That's the good thing about it. And you can find the sectionalizers everywhere. I mean, on the 33 kilovolts power lines, you will see them a lot. You can see them in the rural areas. I mean, outside of the downtown, you will see them a lot. I used to see them every day. They are around us, but they are, again, away from the cities, away from the city centers or downtown areas. What includes? It includes the high voltage bushings, the mounting provisions, the protective tanks. But again, there is no oil for isolation or the other thing. Here is again another picture shows how the sectionalizer is being connected to power lines. Then here is like there is a mechanical trip ring. There is the earthing points. Then there is a control cable. Here is the position indicator. It will say how many is tripping or not tripping. Then there should be, the filter, the other thing, make sure to cover the rest. Now, let's look at a case study in rural areas. Before installation, there will be a long outages. After the closer and two sectionalizers, there will be a 60% improvement in the power system reliability, 45% fewer customer interruptions, and the thing about it, which is reduce the power outage as well. So the sequence, then assume the recloser did time, number one, 0.5 seconds, the number two, 10 seconds, and so on. Then the counting two times for the sectionalizer will trip. The sectionalizer opening time around 1.05 seconds. The sectionalizer is not as fast as the circuit breakers, therefore it will take a specific period of time. Here is, we will assume we have a parallel big closers. In this parallel closers, it will look out after the third trip. So how is the thing going on? Assume there is a power outage at sectionalizer or number 3 here. So when you look at it, the circuit autorecloser circuit breaker is on. Then there's a power outage going on here. The fault's happening. So the first trip happens here. Then it will wait 0.5 seconds because that's what it says in the question. Then the recloser will start re-energized. The power is on. Once the power is on, the fault continues. Since the fault continues, the power will be out. Wait 10 seconds for the next de-energized. Once we wait the 10 seconds, should send a command because it's the second trip. Now here's number 1. Number 2, send a command to sectionalizer number 3 to be on. So section to be off. Sectionalizer number 3 from on to off, but it will wait 1.5 seconds because the question says sectionalizers taking 1.5 seconds. Where is it? It should be located here. 1.05 seconds. Sectionalizers opening time. Then, after that, sectionalizers off. Now there is no reason for the faults. I would say faults is cleared because this one has been isolated. Then after that, wait until the 10 seconds ends. So here the remaining, which is, I would say 8.55 seconds, whatever. Then after that, re-energize. Since there is no fault, then the power will back on without any problem. There is no faults. So there is no third trip. It's just like 2 trips. Okay? So that's the whole scenario about the parallel operation. Now let's go to another example for the series configurations. In the series configurations, which is again, as we said, This is connected to this power transformer. The power transformer, from here there is a lateral, and there is another lateral, etc. Then there is a recloser here, sectionlizer here, sectionlizer here. So 1/3 of the zone here, 1/3 of the zone here, 1/3 of the zone here. Then the operation look out after the fourth. Then the autorecloser dead time is 0.5 seconds. Then after that it will wait 10 seconds. Then wait another 10 seconds. Then each recloser or each sectionalizer operating time, each one, the first one wait 3 times, the second one wait 2 times, then opening time 0.05. Then how the things goes, how these things goes. Look at in here in this example, the fault occurs at this area. Therefore, this is associated with S2. Once the faults happened, the first trip gone happened, then after that, will be re-energized after 0.5 seconds from the autorecloser. Then we realize there's remaining circuit breaker trip. Then, the fault continues. Then the circuit breaker will trip again. Here is the second thing. Then sectionalizer works at 2. Sectionalizer 1 works at 3 counts. Since we are counting at 2, then it will wait 0.5 seconds, or not wait, it will the opening time. Then it will be off. Once it is off, we are below than the 10 seconds. Then waiting until the 10 seconds here, faults cleared. Because we isolated this region. Isolated it. Once we isolated it, there is no reason for the faults. Then, sectionalizer keeps open. After waiting 10 seconds, re-energize the autorecloser. There is no faults, no more faults. No faults. Then it will remain on, and that's it. Here is it. However, sectionalizers 1, it does not change. Why it does not change? It does not change because, the number of trips is below than 3, so it's not working. While S1, S2, it is working or is being off because there is, a fault happens here. Now here's the last example. The last example, assume the fault happens in the middle between S1 and S2. How's the situation? How the system will behave? So the first trip happens here because the first trip. Then the second thing, the autorecloser will re-energized to make sure if this fault is permanent or temporary, then there is a fault remains. Then the second trip. Since the second trip here occurs, the sectionalizer S2 start working. Works after 2. Once we reach 2, it will take, I believe there is, a mistake in this part. Let me do it again in my way. Here is remaining. Then after that, it will take a delay time around 1.05 seconds. Then it will be off and keeps off forever. So after that, because it's working at 2, this will be out of service. Once this out of service, do you think the fault is cleared? No, because the fault is between S1 and S2. So what should I do next? The next thing, there will be another trip after 1.5 seconds. We will need to wait the 10 seconds. After wait the 10 seconds, fault continues. The fault continues, then there will be a third trip. Even though S1 or S2 is out of service, the area after S2 is out of service, but there is still a fault going on. Then once re-energized, the recloser will trip again for the third time. Now, since we did the third time, S1 works after 3. Therefore, it starts working after the third time. It will work for around 1.05 seconds because this is the operation time. Then there will be sectionlizer 1 will work, will be open. Then once we make it open, which means this area now disappears. Now the fault is cleared, right? Then that's good. Here we will say fault is cleared. Once the fault is cleared, then after the end of the 10 seconds, it will back in service the recloser for the third time. Then there is no reason for the power outage. Then it will continue. It will continue, and that's it. So the fault has been cleared after the third time. So again, it's very important to understand when each recloser starts working. Again, this is used a lot, used in Jordan and the worldwide, and especially in Jordan for the 33 kilovolts. The main reason for the sectionalizers is to isolate the fault areas. The reclosers to reduce the number of impacted customers as well. Okay, as a comparison, what we discussed so far, the recloser interrupts the fault currents, has automatic reclosing capability, can detect temporary or permanent faults. Sectionalizers, it does not interrupt the fault currents. It opens only when de-energized, requires upstream recloser, used for fault isolation and feeder sectionalizer. Therefore, these devices, both of them, the combination of reclosers and sectionalizers, improve the power system reliability, selectivity, service continuity, distribution system performance. That's all. Okay, any question? Yeah, I believe that everybody now understand the difference between recloser, sectionalizer, and the other thing which is called recloser relay or auto recloser relay. The difference between recloser and auto recloser relay, again, auto recloser relay, it's not a circuit breaker. It is sending a command for the circuit breaker. While the auto recloser itself, it is a circuit breaker. Sectionalizer, it is a switch, opens at 0 current. Okay, any question? Okay, now I believe we are done with the today's topic. Let me end the recording. Okay.